Hi, this is Mr. Lesage again, and this is our third part, part 3, of our tutorial on factoring expressions from the Math 7a course. Here are two final problems that also call us to be able to do some common factoring, looking for common factors. In this first problem, it gives us this original expression and says, can you find something that's equivalent? Or in other words, when I multiply these expressions together, which one will give me this answer? Well, let's look at the first one. If we multiply 4b times 6, 4 times 6 is 24. We would put the b at the end, so that would give us 24b. That looks good. 4b times 8a. 4 times 8 is 32. A times b would be ab. So 24b minus 32ab is this answer. That's not equivalent. Let's try this one. Again, we multiply 4b times 6b, we get to 24, but now we have b times b, which is b to the second power. That's clearly not going to work here. For this expression, we take 2b times 12. 2 times 12 is 24 with the b at the end. We can multiply the 2 times 17 and get 34. The a times b is ab, so this gives us 24b minus 34ab. That matches. That is an equivalent expression. Let's check our final one. 2b times 12 gives us 24b also. 2 times 17 gives us 34 again, but this time we have b times ab. That would give us an a, but it would also give us, again, b times b, which is b to the second power. So the correct answer to this one is the third one, because that's the only one that we can multiply this number outside the parentheses times the two numbers in the parentheses and get this equivalent expression. Again, this is just the distributive property in operation, multiplying the number outside the parentheses by the numbers inside. In this problem, they're asking us to find the common factor of all of these terms. So let's think about the 21x. What numbers are factors of 21? Well, 1 and 21 multiply together to give us 21, and 3 times 7 give us 21, and then of course we have the x term. So there are the factors for 21x. They're not in order like we've seen them in other problems, but that's okay. We can go through the list and find the ones that are similar. If we look at 18, we have 1 and 18, of course, are factors. 2 and 9, and 3 and 6, and of course we have the x from that expression as well, from that term. And then from the last term, 28, we get the numbers 1 and 28, and 2 goes with 14 to make 28. Can you think of any others? Right, 7 and 4 will give us 28. And of course, in this case, we have also an x and a y that are included in that term. So now we look for numbers that show up in all three lists. Now, this may be a little difficult because they're not in order, so let me just tab over here and put these in order so it's a little simpler to find those. This is something we do often with our work in math, particularly when we're talking about statistics. When we do mean, median, mode, we like to have our numbers in order to make it easy for us to see what is going on. All right, I believe I have gotten all of the numbers. Oh, I can see one problem up here with this list. I forgot to put the x there. Okay, so now we have a nice list in order, so it's going to be a little easier for us to see numbers that match up. Well, we see we have a 1 in common here. There's 2's, but not in the first one. There is a 3 here and a 3 here, but not here. There are 7's in the top and bottom, but not the middle. So it appears that the only number that is in all 3 lists is just the 1. Now, do we see any variables that show up in all of the lists? Well, I certainly see an X in each one of those, but the Y only shows up here. So it would look like, with all of the numbers and all of these factors, the only common factor we have is a 1 and an X, and we could write that either as 1X, or we could just say X is the greatest common factor of these terms.